Hey guys, Mr. Milton here. Today we're going to talk about properties of parallelograms. At the end of this video, you should be able to use the properties of parallelograms to find missing side lengths and angle measures. So to find that missing word, to find missing side lengths and angle measures. So here's a reminder, when we talk about parallelograms, we are talking about all these figures. Parallelogram is a name for that is an umbrella for rhombuses, rectangles, and squares. So rhombuses, rectangles, and squares all fall under the parallelogram family. So as we discuss these properties, we're saying these properties will be true in rhombuses, rectangles, squares, as well as just general parallelograms. Alright, so the structure of this, guys, is that we're going to talk about the properties, but we're going to prove why the properties are true. So I could go out and just say, hey, these are the properties, and that's what I'll do right now. I'll tell you, this is property 1, this is property 2, this is property 3. But then I want to prove why they exist, so or why these have to be true. So while you need to know that this works, it's a good practice to know why it works. Okay, so first property is that opposite sides of parallelograms are congruent. Okay, we'll go back and prove this in just a second. Second, that opposite angles of a parallelogram are congruent. And the third property is that the diagonals of a parallelogram bisect each other. Okay, so we can just know that and use that, and that's okay for some, but I want to make sure you know why that works. Okay, so those are the things that we need to know. I'm going to go back and show you why it works, and then we'll do some examples of using that information. Okay, all right, and so we'll show why it works by doing proofs. Okay, really we're proving that it works all the time. So first, we want to prove that opposite sides of parallelograms are congruent, and what we're going to do is just start off with the given statement that ABCD is a parallelogram. So if we're going to prove that opposite sides of parallelograms are congruent, we're really proving that AB is congruent to CD and that BC is congruent to AD. And we're going to do that using triangle proofs, really. And so we'll start by saying the given statement ABCD is a parallelogram, and that was given information for us. From there, since we know that it's a parallelogram, then we can use the characteristics of a parallelogram, and that being that BC is parallel to AD, that the opposite sides are parallel to each other, and that AB is parallel to CD. And we can say that because that's the definition of a parallelogram. Okay, so I'm going to mark that on my diagram for me to use. And now anytime I think of parallel lines, I'm thinking alternate interior angles, corresponding angles, maybe same side interior angles. But here I see alternate interior angles. So I'm able to say that angle 1 is congruent to angle 4 because of the alternate interior angles theorem. I can also say by that same logic, by using that BC is parallel to AD, that angle 2 is congruent to angle 3. Okay, and so I'm going to put that in the same step. And now hopefully you noticed already that AC is congruent to AC, or CA, because of the reflexive property. And so I can say that triangle ABC is congruent to triangle CDA because of angle side angle. And because I can show that those two triangles are congruent, then I can say that BC is congruent to AD, and I can also say that AB is congruent to CD. And both of those by the CPCTC, or corresponding parts of congruent triangles, are congruent. Okay, so some people are satisfied in knowing, hey, this is true, and some people want to know why it's true. This is why it's true. So opposite sides of parallelograms are congruent. This is why. Okay, have to know this, good to know this. All right, property 2 is that opposite angles of parallelograms are congruent. So we're going to prove that here, and so basically we're proving that angle N is congruent to angle Q, and that angle M is congruent to angle P. So again, these are opposite angles, N and Q, M and P, those are opposite. Double dot that so we can see that those are the two I'm talking about. All right, so we'll start this the same way. They gave us that MNQ, or MNPQ, is a parallelogram. That's given. From there, we can say that NM is parallel to PQ. Because that's what parallelogram is. And in the same thing, we can say that NP is parallel to MQ. Again, in a parallelogram, we know that opposite sides are parallel. Okay. Now, like I said, when we think of parallel lines, we think of alternate interior angle, corresponding angles, and same side interior angles. And here I can see the same side interior angles, and that's what I'm going to use here. And because of same side interior angles, I can say that angle N plus angle M equals 180 degrees. Same side interior angles theorem. Okay. I can also say that angle N plus angle P equals 180 degrees from the same logic. Okay, so these are same side interior angles, these are same side interior angles. And because they both equal 180, I'm actually going to set this up a little bit differently, and we're really going to prove this one. We could prove N is congruent to Q, but I'll prove this one, and you'll see that you would be able to prove angle N is congruent to angle Q the same way. Okay, and so since these two equal 180, I can just say, hey, angle N plus angle M equals angle N plus angle P. And I'm just doing that from substitution. Since I have two things that equal the same thing, I can substitute and flip them in how I want to. And if I subtract angle N from both sides, then I can see that angle M should be congruent to angle P. And I did that from subtraction property of equality. Okay, and so I've proven that angle M is congruent to angle P. I could do the same thing with N and Q using same side interior angles theorem. So again, you have to know that opposite angles of parallelograms are congruent. It's good to know that this is why they're congruent. So we've proven that angle N, angle Q have to be the same, angle M, and angle P have to be congruent. Okay. Finally, our third property of parallelograms that we need to know is that the diagonals of a parallelogram bisect each other. Okay, and so here's how we do that. They gave us that ABCD is a parallelogram. ABCD is a parallelogram. That was given. All right, from there, we're going to use the same information. They want us to prove that AC and BD bisect each other. And in other words, if they bisect each other, it means they cut each other in half. So we could say that BE is congruent to DE, and that AE is congruent to CE. Okay, so that's what it will mean if they are bisect each other, they cut each other in half, or they may have two congruent pieces there. And so that's what we're going to prove. We're going to start off by using the fact that opposite sides have to be parallel to each other. So I'm going to say that AB is parallel to CD. Again, definition of parallelogram. Okay, and by using this, we're just saying if it's a parallelogram, this has to work. So anytime it's a parallelogram, this has to work. All right, and really I'm going to just need that side, because now that I have that, I can say that angle 1 is congruent to angle 4 because of alternate interior angles theorem. I'm going to use a property that we just discussed earlier, that the opposite sides have to be congruent, and so that AB would be congruent to CD, because in a parallelogram opposite sides are congruent. So I'll just say definition of parallelogram, because now we've added that to our definition of a parallelogram since we know that property. And then I can say that these two angles, angle CED, I'll start the other way, angle AEB is congruent to angle CED because they're vertical angles. We know that vertical angles are congruent. Okay, and so what I've shown here, and what I have here at least, is that triangle ABE is congruent to triangle CDE because of angle side. And so now I can prove that BE is congruent to DE by CP/CTC. And I can also prove that AE is congruent to CE by CP/CTC. Okay, again, you need to know that diagonals in a parallelogram bisect each other. It's good to know that this is why it's true. Okay? All right. So let's use that information now to solve for some values. This is how you'll use it. This is where how most of your practice will look. So they say find the values of the variables in each parallelogram. They give us these. Since it's a parallelogram, we know that opposite sides have to be congruent, and we can use that to set up our equations. And I see here that I have 3x minus 15 equals 2x plus 3. It's an equation I can solve, and I'll get x equals 18. Subtract 2x from both sides, add 15 to both sides. X is 18. Now that I know that x is 18, this other equation is going to be easier for me to solve. I can say 2y minus 1 equals, and instead of saying x plus 7, I can say 18 plus 7. So 2y minus 1 equals 25. Add 1 to both sides. 2y equals 26. Divide by 2. Y equals 13. Okay. This question involves diagonals. Notice, the diagonals of a parallelogram bisect each other. So use this information, set up your equation, your system, and solve. I'll do it. Okay, so here I have y equals x plus 1, and also 3y minus 7 equals 2x. Okay, in this system of equations, I can use substitution to solve, and now y equals x plus 1. Instead of using y in the second equation, I'm going to use x plus 1, or actually, you're going to do that. So do that to solve for x, and then once you solve for x, plug it in to solve for y. Final theorem for today, it says if 3 or more parallel lines Three or more parallel lines cut off congruent segments on one transversal. Then they cut off congruent segments of every transversal. That they intersect, of course. Okay, and so here we see that in this transversal, this line that goes between the three parallel lines, they're marked that these two are congruent. So because those two are congruent, then we know for sure that these two are congruent, and also that these two are congruent. Okay, and so then we can answer the question, what's pH? Well, pH is congruent to Hg. Hg is 6.7, so pH is 6.7. What's Km? Okay, well, KL is 4.2, that means Lm is 4.2, so Km would be 8.4. Alright, so there we have it. Again, the three properties of parallelograms that we need to remember is that opposite sides of parallelograms are congruent, opposite angles of parallelograms are congruent, and the diagonals of parallelograms bisect each other. Okay? Alright, see ya.